My name is Bonnie Gauss, and I'm the head of communications here at Skellig Automation. Today, I'm going to take you through an introduction to the software development lifecycle. I've developed this training after years of working within the SDLC. As we go through this, I will not be reading off of the slides so much, so feel free to pause as you need. So, what is the SDLC? The software development lifecycle is exactly what it says it is. It is how you develop software. It is a step by step process that makes it easier to keep track of everything, no matter how complex your project is. It helps you anticipate any changes, and there will be changes. And it also helps guide you whenever you need to remediate any issues that crop up whenever you're developing. It's really important to note that the SDLC is different for every team. If you are working for an integrator, it's going to be different for every client. They may use different words, they may use different models, but ultimately there are some common threads, and we're going to cover some of those today. First, we'll go through some SDLC acronyms. If you've watched my videos before, then you're familiar with IQ, OQ, and PQ. These are your qualification tests during validation. GAMP 5 is the ISPE guidance for good automation manufacturing practice. It is a risk-based approach to making sure that your GXP computerized systems or your software is compliant with all regulations. And then you have a lot of different specifications. We won't talk a lot about these, but you're probably familiar with them if you're in this space. You've got your functional specs, your functional requirements, user requirements, design specs, and configuration specifications. So I have distilled the SDLC down to 5 main steps. You'll notice that some of these steps are actually combined, and often you'll see that there are 7 steps to the SDLC. I've combined the first 2 and the last 2 because I think they're so intertwined that they don't necessarily need to be separate. Stage 1 is the planning and analysis stage. This is where we collect the desired requirements and then analyze them against what we can actually do. You want to consider the desired functionality of your system, which means that it solves a problem. What is your problem? What are the alternate solutions other than the one that you will be designing as part of this process? What's your cost benefit analysis? How feasible is this project? Once all this analysis is complete and the team gets the thumbs up, then you actually get to plan the project. This will include your timelines, your project planning. You'll go ahead and plan how you'll do the testing once you get further along. You can define your budget and you can allocate resources. There are more plans that you may encounter, but these are 5 that run as a common thread through pretty much every SDLC project I've been a part of. Stage 2 is design. So this is where the software engineers take all of the requirements that you amassed during stage 1, and then they begin to design the software to accommodate those user requirements. They're going to have to decide whether or not they want to use pre-existing modules or if they want to create all new ones. They will be looking at the best tech and the best tools for the final product and also for the development itself. Stage 3 is your development stage. This is where the software engineers are actually developing the software. During this stage is where gaps will tend to crop up. You'll see what you're missing, what doesn't actually work in practice. This is where scope changes happen. I don't think I've ever been on a project that didn't include a scope change. So you can expect revisions to the approved planning that you did all the way back in stage 1. So once development is finished, we move on to stage 4, which is the testing phase. Each testing phase is going to be project dependent, but in general, there are 2 main categories of testing. You have black box testing and white box testing. Black box testing is testing your external system behavior. The tester isn't going to be familiar with the software at all, and so this is going to be your functional and regression testing. White box testing is typically done by the software team, and it's going to be testing the software implementation and impact. The tester is usually deeply familiar with how the software was developed and how it works, and this can often include path and loop testing. While the development team actually still owns the code, there are other types of tests, and there are a lot of tests on these next 2 slides, so bear with me a little. First is internal testing. This is where the software team tests to make sure the code actually works. If you skip this step, you'll often find that you delivered a ton of errors to your user, and they don't tend to like that. Factory acceptance testing makes sure that all the user requirements have been correctly implemented and function as they are expected to do. So this is also done by the software development team. Any defects that are found during this stage, and there will be defects, are risk assessed, and they will either be sent back to development for remediation, maybe all the way back to the planning stage, or they'll be moved forward to fix it during a later software release. This type of testing is usually witnessed and approved. If you have a client, so say that you're a system integrator like we are, the client will witness and approve this typically, or someone acting on their behalf will do so. Just in general, your end user will witness and approve this testing. This is often called user acceptance testing as well. For systems that already exist, regression testing makes sure that nothing outside of the scope of the project was impacted by the new code that you developed as part of this project. Configuration or static testing makes sure that all the objects are configured per spec. Normally, this doesn't involve actually executing the software. This might be set parameters, it might be your alarm management. Functional testing occurs when you actually run the software to make sure it works. This is when you'll do your interlocks and permissive testing. You'll test your sequential function charts, your function block diagrams. You'll test all of your logic. If your project includes module testing, you'll test your specifications as specified in your project plan and make sure that all modules meet spec. This is a mix of configuration and functional testing and has similar example strategies. Integration testing is conducted following configuration, functional, and module testing. It's typically performed by tracing your user requirements to your functional spec. This is where you'll see your requirements traceability matrix. Finally, stage 6 is implementation and maintenance. This is when the ownership of the code moves away from the software development team to your client or your end user, and that code actually gets implemented on site and then tested to make sure that it works. This testing may also be called different things for different end users, so check your end user to see what they're calling this testing. This stage isn't just testing, it also includes personnel training. It includes setting up your maintenance plans going forward throughout the entire life cycle of your process. It also involves your calibration schedules and any transition activities. The implementation testing or validation in the life sciences has 3 typical sets of protocols. These are your IQ, OQ, and PQ. Your IQ makes sure that your hardware meets design spec and manufacturer requirements and your installation checklist. The operational qualification ensures that the user requirements are met whenever you're operating within the manufacturer's defined operation ranges. And your performance qualification tests the entire system to make sure that the user requirements are met while you're using the software as intended. This is called intended use. Then we move on to the maintenance part of stage 6. Typical operation is going to have scheduled periodic maintenance, and that can include equipment maintenance, calibration. Often you'll have to have a set revalidation period. There are all kinds of activities that can happen. It's going to be defined by the manufacturer. When the life cycle itself has come to an end, the process must be retired and decommissioned, which is a controlled shutdown of a retired system. The most important part of decommissioning is safety. Now that we've gone through the 5 stages of the SDLC, let's look at a couple of models. There are over 50 different SDLC models that are in use in industry. There are probably more, actually. The choice of model is going to depend on what time you have, how much your project budget is, and the number of defects that are remediated during the project. Clients may stick to one, they may squish a few of them together and hybridize, or they can use different models for different projects. So being familiar with several of them can always be helpful. Here we see the V model and the waterfall models. These are probably the most common that I've seen. In the life sciences industry, we often use the V model because it's used heavily in GAMP 5. And as you can see, the arrows between each side of the V model, your unit testing tests your detailed design, your integration testing tests your high-level design, and your system testing tests your user requirements. Whenever you need to make a change, it starts again at the left side of the V and moves its way through. The Kanban board is another common one that you'll see. You split up tasks into however many are required for the code. Sometimes you'll see this done on Post-it notes, hence the thumbnail for this video. You will track each task by categorizing it into where it is, whether it's in a backlog, it's actively being done, whether the work you've done is in review, and when it's finished. The Scrum framework, just as an overview, because there are entire classes on Scrum. You also split up your software development into different tasks, and then you split those up into sprints. Each sprint takes a maximum of 1 month. You'll have a Scrum Master who gathers the team every day. And during that daily Scrum meeting, you'll talk about your progress on your tasks, if there needs to be any refinement of your backlog, or if there's anything that needs to be done differently. A project will go through several sprints in order to achieve big goals. Each sprint should be potentially releasable by itself, so it needs to be a bit self-contained. After it's finished, you review the sprint and you do a retrospective, and then you begin on the next sprint. Finally, I want to talk about data integrity because I always talk about data integrity. As you can see at the top here, I have a list of categories 1, 3, 4, and 5 from GAMP 5. You'll notice there's no category 2, and that is on purpose. Depending on the category, your data integrity and security are going to look different. It is important to consider your data integrity and security throughout the entire SDLC. It is possible to go through and retrofit these into your process, but if you build them in from the beginning, it's going to be much easier on you and your team. It also becomes much easier to meet or exceed regulatory requirements and catch potential issues before they ever become a problem for you. This also, most importantly for project managers maybe, it helps you prevent over or under testing the system. Here is a list of the attribution for the graphics used. And that's it today for our base level intro of the SDLC. Thank you so much for joining me. If you find this content helpful, be sure to like and subscribe to our YouTube channel and check us out on LinkedIn as well. Comment below if I've missed any parts of the SDLC that you frequently encounter. If you have any questions, feel free to email us at info@skellig.com, and we'll see you next time. Thank you.